Here we would like to look at the product of three matrices. My recommendation, of course, would be to do, for example, the last two, and then you would get a matrix. You would compose it with the new one. And so let's say we start with this strategy. How would the multiplication of these two specific matrices look like? Precisely as follows. So we would take the row in a dot product with the column. And the place in which it lands is always the intersection of the rows and the columns. So upper left. Same thing now. 1, 1, but with the other vector 0 and 2. I do this 2 more times. Then I am done. So this is the matrix we will get. It's a matrix which has the results of 4 dot products stored inside of it. And effectively, this is really what matrices are. In a somewhat practical sense, you could say, maybe in a somewhat algorithmic, algorithmic / practical. This doesn't really hold any deep meaning to it. Well, of course, there are always deeper meanings, but I don't think we'll be discussing any of these in this tutorial. And let's say I apply the same logic that I've just applied now. So this is a matrix. This is the first entry, second, third, fourth. I mean, order doesn't... You could go over them in any order you like, but these are separate entries. What we did initially was we took the row from the first matrix with the column from the second matrix. So I'm going to do just that. This is the row. I'll take this with the column 3, 0. Now I know this will be confusing because the row is really, it's a dot product of some other terms. I am deliberately doing this. I'll tell you this. I am deliberately making this difficult. Well, not difficult. I just want to show you something that's cool, I think. So this is a vector, a row vector, which has dot products as its input. I take the same row and compose it in a dot product with the other vector, which is 3, 3. I like how it fits perfectly. I proceed similarly here. This is only the second row. I multiply this by the column. And I do this one more time. So I get this thing here. I know this is very big, but this is really the solution to the problem. If you compute all 4, then this will give you the solution, 100%. And now let me just highlight some of the things we did. So 3 zeros are here. 3 zeros are here. The 3 3s are coming from there. And these are row vectors, which include row vectors, you could say. Maybe I'll give them a different color. Maybe dark blue is nicer than red. to distinguish. So this is the first entry. This is the second, this is the third, this is the fourth. Let's actually try to compute this matrix. I don't think it will be too difficult. Could be wrong. But here's the thing. The goal really from what I'm doing right now is to accommodate you to the perhaps a bit unnecessary abstraction that we have here. And I think if you get exposed to this type of construction, I think it is very good for your understanding. So this is a row vector which has dot products as its entries. This is the first entry in our row vector. This is the second entry. I multiply the first entry with the first entry here, and I multiply the second entry with the second entry there. So I get this gets multiplied by 0, and the first one gets multiplied by 3. And as with any dot product, you always add the resultant terms. This is amazing because this is just 0. I don't need to worry about it. And then what's next? Let's do the other one. So I want to distribute this 3 over this first component and this 3 over the second component. This is 3. And this is also 3. And don't forget to add them. So it will give you some number. I do the same thing here as I did earlier. Here I'll get my 3 and here I'll get my 0. And when I get my 0, we'll cancel out just like we saw. We'll do this one more time here. 3 and 3. So I think this is great. I copy this and I move on and compute now the remaining the remaining values. So this is 0. I don't need to worry about it. I'm happy that it's getting smaller now. It's taking the whole page. We could take the 3 as a common factor if you think about it for a moment. So whatever the resultant of adding these two numbers, well, yes, numbers, because the dot product returns a number. I just multiply it by 3. So now it's even more compact. Perhaps now it is a good idea to start computing the values. I've been procrastinating on this for very long. So 1 times 2 is 2, plus 1 times 2, which is 2 again. So that's 4. Now 3 times 4 is 12. So maybe I should write. This should be 12. Here I think it is exactly the same thing. It looks like it. So this will be also 12, I hope. I haven't made the mistake there. This is 4. This is 4. This is 2 and this is 2. And if this is the case, then this is 6. And you multiply by 3, you get 18. And 18 as the answer. I was a bit worried in the last minute because I thought this wouldn't actually be the solution. I thought it was a bit fishy that the values are repeating, but it's okay. So this should be the answer. You could just do it, as normal human beings do it, and compute the first matrix and then compute the second matrix, because normally this is how sane people do it. But you're not so sane and you would like to discover weird and complicated constructions, then perhaps here this is a good use of your time. I hope this was a very good use of your time.